So looking at the state of a system, the definition So the state of the system is basically a description of the condition of the system at a given instant from independent property values. So from a number of property values, we can then specify the state that the system is at. And once we have specified the state of the system from this small number of independent property values, usually 2 through the state postulate of thermodynamics. If you have 2 independent intensive properties, you can specify the state. Once you have done that, all other properties have been defined. So that is the state of the system. Another term that we will use within thermodynamics, we will talk about equilibrium. Equilibrium is kind of what it sounds like. We refer to thermodynamic systems as being in a state of equilibrium. And what we say is that properties are only defined when a state is in equilibrium. So what does that mean? That means that there are no unbalanced potentials or driving forces within our system. So to have the state of equilibrium, you would need to have thermal equilibrium within your system, for example. You could not have temperature different at one point within the system from another. Because when you have that, you're going to have energy flow or conduction, convection. You'll have an energy transfer process underway. So with the equilibrium condition, we're assuming that we are within a state of balance within our system. Another thing, you would not be able to have pressure differentials within your system because pressure differentials would drive. So you can have no unbalanced potentials or driving forces. Within the system. So that's what we refer to as being the state of equilibrium. Another thing that we want to look at is process. We will talk about processes quite often throughout this course. And what a process is defined as being the transformation of a system from one state to another state We usually call these two states, the beginning and the end, we refer to them as being the end states of a process. Within thermodynamics, what we often do, we examine processes or cycles, which I'll get to in a moment, but we use a process diagram in order to know where we are within the different properties and states that we have. So a process diagram I'll draw an example here of a pressure volume process diagram. So usually we have some of our properties. So here we have pressure and volume. And in this particular process, we could be going from state 1, which whenever you look at a process diagram, it's usually written as a big round circle or a ball, if you will. And there will be a number next to it, and that denotes one of the states. And we go to another state. So those are the two end states that I referred to. And notice that at each of those states, we have a defined volume and a defined pressure. So here we'll be going from V1 to V2. So that's the change in volume. Now, there are different paths that you can go on when you go from state 1 to state 2. And so often what we will also do is we will sketch the process path, and so that we know which direction it is going, we indicate it with a little arrow. And so that arrow tells us the direction with which our process is going, and we call that the process path. Now, when you're looking at a process, a complete description requires a number of things. First of all, just like I showed you on the process diagram, we need to know the end states. You need to know where it begins and where it ends. So we need to know the end states. That was 1 and 2 on the previous process diagram that we just looked at. We need to know the process path. So which way is the process going, and which pressure and volumes does it go through as it goes from state 1 to state 2. And the other thing we need to know is, remember we're dealing with systems, we need to know the interactions across the boundaries. So what can cross the boundaries? Well, we talked about that earlier. We said that heat can cross the boundary. Remember, we said that for either an open or a closed system. Work can also cross the boundaries. And finally, in the case of an open system, mass can cross the boundaries. So those are the three things. So if we know, let me underline those, if we know the end states, if we know the path, and if we know heat, work, or mass, then we have described it completely. Now, when a system undergoes a change of state, so like we're just looking on that process diagram going from state 1 to state 2, the change in the properties, or the change in the value of the properties, does not depend upon the process connecting the two end states. So you can go through any process path, and the properties at either state 1 or state 2 will not change. However, the work or the heat transfer could change depending upon the process path. So we say that when a system undergoes a change of state, the change in value of a property, remember we've defined what properties are. They can be either intensive or extensive, and we talked about a lot of different ones. But it does not depend upon the process path. Now, if we do have a value that does depend upon the process path between the two end states, that means that that quantity is not a property. So if we're using some sort of property and we find that it is dependent upon the process path between two end states, that tells us that that is not a property. And examples of these are heat, work, and mass interactions.